This is lesson 1.7, and we're going to be talking about solving linear inequalities. So these are linear equations that we've been seeing so far throughout the unit. But what we're going to do is we're going to introduce inequalities, which are these symbols. And so just to review, a less than symbol goes this way. Okay, greater than symbol goes this way. So the bigger number always goes in the direction of the opening of, it almost looks like a mouth. And the smaller number would be on this side, which is where the corner is. So if I were to use the above less than symbol, the first number would be less than the number afterwards. Okay, and then there's less than or equal to, which is a less than symbol with an equal sign underneath, and then the greater than or equal to symbol, which is a greater than symbol with a line underneath. And so, for example, if I wrote a statement like this, this would mean that x represents all the numbers that are less than or equal to 8. And so that would be 8, and any number smaller than that. Okay, decimals, fractions, whole numbers, it doesn't matter, negatives, positives. In this example, this would be x is any number greater than or equal to 8. So that would represent 8 as well, including all the numbers larger than it, decimals, fractions, negatives, positives, and so on, up until forever. Okay, so what we can do is we can write them in the equation form, or we can draw them on a number line. So what you see in green is the equation graphed along a number line. And so when you draw a number line, use a ruler. I like to start with a 0 in the middle so that you can represent the right-hand side with some positive numbers and the left-hand side with some negative numbers. And it's almost like a scale for a graph, so make sure that you're going up and down by the same amount. So this one is going up by ones. If I have to draw x is less than 4, then you're looking at 4 and all the numbers that are less than that. And so notice that I've highlighted this side of the number line, but with an open dot. So this is what we call an open dot. Now, because this symbol is just a less than symbol and not a less than or equal to symbol, we're basically saying that let's say the group of numbers that x could possibly be that is less than 4 represents anything up to almost 4, so 3.99999. But because there is no equal line underneath this inequality, you're not actually including the 4, and so that circle is going to remain open to represent that there's a hole there. You're not including 4 in this set of numbers. Okay, and the arrow represents it going on forever in the negative direction. Now, x is greater than or equal to 0 means that I am actually including the 0 as well as all the numbers bigger than it. So we put an arrow at the very end to show that it goes on to positive infinity. If we're talking about, say, like a situation, to be an official school club, a club needs to have 3 or more members. In this case, it's a little bit different than the above two cases. The above two cases are what we call continuous. So it continuously goes on forever and includes all decimals, fractions, and so on. But when you're talking about, say, 3 or more members, you're talking about a discrete set of numbers, so only whole numbers, because obviously you can't have like 3 3/4 of a member, right? And so we are including 3 members, so we're putting a dot, a closed dot on that one, but also any numbers more than that, so 4, 5, and so on. Okay, so let's talk about some of these now. So D is saying any integer, so those are negatives and positives including 0, for x, and the integer x is at most -2. So when they say is at most -2, it means that -2 is the highest, and they're only using integers. Integers are whole numbers, so notice that I haven't highlighted with an arrow or like a solid line like up here. So we don't include any of the numbers in between, and that's why we put just the dots on the whole numbers themselves, but it says at most is -2. So that's the highest, and then you're going to go down forever. Okay, so this would be another example of a discrete set of numbers. Now, when you have two sets that they're giving you, and they're saying, okay, what is the answer for both sets together? What you're going to do is you're going to imagine the blue one first. So any number greater than or equal to -3. So here's -3. And if I were to use a blue marker, I would highlight with a closed dot everything on this side because it's bigger than -3, including -3. Now with red, I have another set of numbers, which is anything less than or equal to 2. So if I were to draw that, I would draw a red closed dot here and go downwards forever. So what do both of these sets have in common? And that's what the answer is for both of the sets together. What this is basically saying is, what is bigger than -3 and also smaller than 2 at the same time? So imagine the blue line and where the red line would be crossing each other. So this is a set of numbers that satisfies both of those criteria at the same time. So your answer would be x can be anything that's in between the -3, including the -3, all the way to 2, including the 2. Now, if you run into a situation where you do graph both of them, so this is x is less than or equal to 0, so we have that right here, and x is greater than or equal to 1, so we have a closed dot, and that's this way. If neither of those arrows overlap, it means that those are separate conditions and there are no x values that satisfy both conditions simultaneously. So because we're being asked what x values satisfy both of those criteria simultaneously, and you'll notice that neither of the arrows actually overlap each other, which means that there are no x values that are smaller than 0 but at the same time greater than 1. So our answer would be there's no answer. There's no solution for x. Like none of those values exist. Okay, so let's get into solving inequalities. When you're given an equation like this, it's like you're just solving for x like normal. And so if you have 3x minus 17 greater than or equal to 34, treat that inequality just like you would a regular equal sign. So you would bring the 17 over to the right-hand side, it becomes a positive. Don't write an equal sign, just write the inequality as you see it in place of the equal sign. Okay, add those two together, you get a 51. Divide the 3 out on both sides. Now here's a little bit of a tip. If you were to have divided a negative number out, so divided by -3 on both sides, it actually switches the direction of the inequality around. So that's just a little tiny trick, okay? And that's actually written right here. All right, so just as a pointer. So my answer for this question, what numbers actually satisfy this equation so that our answer on this side would be greater than or equal to 34? The answer is any number that is bigger than or equal to 17. So if I put any number in here, x, that is bigger than or equal to 17, say like 20 or 100, if I multiply that number by 3, minus the 17, it should be bigger than 34 or equal to 34. Okay, and if I wanted to represent that in terms of a number line, you're just going to draw a giant number line. Again, try to get a 0 in there. 17 is a big number, so I put a lot of positive numbers in there. And normally what I would do is I would put a closed circle right on 17 and put an arrow on forever this way. But notice that they put a condition on the question, which was you have to be talking about only integers. If so, then you're just going to be putting solid dots and it would be a discrete set of numbers because you're not talking about any decimals or fractions. Okay, so let's take a look at B. -8x is less than 32. So again, treat that as an equal sign. Divide both sides by -8. But remember, if you're divided by a negative number, you're going to change this, the direction of the inequality. That's just one of the rules. So 32 divided by -8 is -4. And your answer would be any number that is bigger than, that's why I have an open circle right there, -4. And since we're talking about integers, I'm putting a solid dot on all of the whole numbers. Okay, if I was talking about any real number, as in like any number at all, it would just be a solid arrow that goes this way with an open dot right there. Okay, so I ran out of space with this one. Let's just jump to that one really quick. Okay, so this is that third example. Solving the exact same way, moving the 5 to the other side. Okay, get a -5. And then let's move the 3 over as well after I subtract. That would be a multiply, right? We're going to multiply both sides by 3. So I'm going to get a -6. And remember, I'm dividing by a negative number to get rid of this negative, so I have to swap the direction of the inequality. So this is what I get. Okay, so anything smaller than 6, including 6, but I'm talking about all of the integers, and I probably should have also put dots right in between to represent all the odd numbers as well. So all whole numbers. Okay, so this is the last example. Now we're talking about word problems. So Peggy's checking account allows her to write checks without paying a service charge, provided her monthly balance stays above 200. So what you're thinking about is that the money that she has in the bank just has to stay above 200. Now it doesn't say that it includes the $200, just above. So we put an open dot and then we put an arrow. Forget about this one. This one's a little bit weird. Didn't make the lesson, but that I don't know why they included this. But let's talk about this one instead. Steve's project will take at least 8 hours. So at least means that it could take minimum 8 hours. So we include the 8 hours, and then everything above that, it could take more time. We don't know. So that was a fairly quick lesson, I guess, on inequalities. So you saw a bunch of just solving linear inequalities in word form, but then also in algebra form.